Okay, so this is our formal lab on electric potential with balloons. So we were interested in understanding how charges play a role in balloon repulsion. The research question that we are investigating is what is the charge on each of the balloons? And our goal is to determine the magnitude of the electrical charge of the two balloons through our experimental design. We assume that the balloons have the same charge and that they're the same mass and that they have their charge in the same way. The reference point that we're using is the middle of the balloons, and we're assuming that there's no movement in the X or Y direction, and the place where we're going to take our calculations is when they're at their furthest distance, therefore net force is 0. The physics models that we have are a system schema, and we also have energy bar charts, assuming that when the balloons are at their closest, they have all electric potential, and as they begin to repel, kinetic energy increases while electric potential decreases, and then when they're at their furthest distance, we just have kinetic energy.
For our experimental design, we had the balloons, the string, hair, tape, and a table, and our string length was 29 centimeters, and our height of the table was 73, and our balloon mass was 2.5 and 2.7 grams. And then we kept our camera distance 1 meter and our frame rate of track rate 30 frames per second. And our independent variable was the charge of the balloon, while our dependent variable was the radius between the balloons. And in the next slide, we have our experimental design drawn out. So basically, we have the force of tension as a string on both of the balloons. And because we're assuming that both of the balloons have the same mass, we're gonna just calculate the charge of one and then assume that's the same on the other balloon. And so we were able to use the math that we learned throughout this unit and figure out that the force of tension is also equal to the force of tension in the y direction is equal to the force of gravity, and the force of tension in the x direction is equal to the electrical force. And then we're going to use the Pythagorean theorem and get the radius of tan theta, because that's equal to the force of the tension in the y over force in the x direction. And then once we got the force in the x direction, we would use the Coulomb's law that we learned this year for our force equation and find the charges for both of the balloons. And so for our data for our first trial, we used Tracker. We got our theta to be 71 degrees, and our distance was about 0.263 meters between the balloons. And then in our second trial, we had theta as 72.7 degrees, and our distance between the balloons was 0.252 meters. And for our last trial, we had our theta as 72 degrees and our distance as 0.279 meters. And so for calculations in trial 1, we use force equals mass times gravity to get the total amount of newtons. And then we used our equation as shown earlier to figure out what the electrical force was. And once we got that, we put that into the equation, and we had the assumption that both Q1 and Q2 were the same. So for our first balloon trial, we got 8.19 times 10 to the negative 6 coulombs per balloon. And for the second equation, we followed the same kind of math, and then we got 7.49 times 10 to the negative 6 coulombs. And for our last one, we got 8.34 times 10 to the negative 6 coulombs. And here's like our total amount, or each of our trials, what we got for the charge of the balloons. And then we just averaged them out to get the average total charge of the balloons. And that was 8 times 10 to the negative 6 coulombs.
Some qualitative error that we have is we were unable to keep the balloons from not like rotating, and then tracker calibrations may have slight errors in them. Quantitatively, we assumed in our calculations that the balloons were of the same mass, but they in fact really weren't. The average mass was 2.6, but they differed slightly from each other. Our standard deviation was about 0.43 and our 0.45, and we calculated a total 23.8% overall percent uncertainty. In conclusion, while the results indicate electric force, the charge of each balloon is still very small. It can be determined that the charge of the balloons is the same, and we allowed us to come by this through our experimental setup. And we calculated that our average charge was 8 times 10 to the negative 6 coulombs, and our average distance was 0.265 squared. And that is our experiment. Thank you.